All right, ladies and gentlemen, here's, like I said, the notes for section 1.4, and I'm going to go ahead and redo the first section for you, and then we'll go through the rest of it. So what I would like to do again is to show you the first one. So section 1.4, solving linear systems. The algebraic methods used to solve systems of linear equations in two variables can be extended, to solve a system of linear equations in three variables. Example, solve the system of equations 3x plus y minus z is equal to negative 6, 2x minus y plus 2z is equal to 8, and 4x plus y minus 3z is equal to negative 21. So remember, I told you earlier today that we should label these 1, 2, and 3. And in this case, I said use elimination or substitution to make a system of two equations in two variables. And again, I told you with this one here, I was going to use elimination. With the second example, I used substitution. So on this one right here, again, remember I told you to look at this here. So look at those right there, and then those right there. So that kind of tells me I'm going to take 1 and 2. So I'm going to take 1 plus 2. And as I did before, I'll make it a different color. So I'll say 3x plus y minus z is equal to negative 6. And then the second one was 2x minus y plus 2z is equal to 8. And remember on this one here, what was nice is that when we added them, the y's went away, and we got 5x, because we added, plus z is equal to 2. And remember, I told you to call this one now equation 4. Same thing, I'm going to use 2 plus 3. So again, I'll have 2x minus y. Oh, I'm sorry, here, let me go back and change it to the color blue again. So I'll have 2x minus y plus 2z is equal to 8. And then I have 4x plus y minus 3z is equal to negative 21. And I apologize for that, but I'm not going to redo it. And again, I'm going to call this one here 5. And again, minus y plus y, those two are going to go away. And in this case, we'll have 6x minus z is equal to negative 13. So that was our first step. Again, remember, I was looking at if they were the same coefficient, in this case 1 on both of them, and I looked at a plus and a minus, and then that's what kind of helped me choose those two. So step 2, solve the system of two equations for both of its variables. So now again on this one here, and it just kind of worked out here that I lucked out, I have a plus z here, and I have a minus z here. So on this one here, again, I'm just going to add 4 plus 5. And again, I'll change that to blue. And in this case, I'll have 5x plus z is equal to 2. And then I'll have 6x minus z is equal to negative 13. So again, I'm going to add those two. And again, plus z minus z goes away. So in this case, I'll have 11x is equal to negative 11. And then I'll get that x is equal to negative 1. Okay, so now remember I told you to substitute. Negative 1 for x into 4 or 5 to solve for z. Again, I chose 4. So remember, wherever I see x, I'm now replacing it with negative 1. So I'll have 5 times negative 1 plus z is equal to 2. I'll have negative 5 plus z is equal to 2. I'm going to add 5 to both sides, and that'll give me that z is equal to 7. All right, and then remember, again, I'm redoing this. I'm hoping you remember, because it is review. Substitute the values for step 2 into one of the original equations. So when I say one of the original equations, I'm talking about 1, 2, or 3 up there. Again, I chose the easiest one. I chose 1. Again, in this case, we're all kind of easy. But again, on that one there, wherever I saw x, I'm replacing it with negative 1. Then I have plus y. And wherever I saw z, I'm replacing it with 7. And that'll equal negative 6. So I'll have negative 3 plus y minus 7 is equal to negative 6. I'll get that y minus 10 is equal to negative 6. And again, I'm going to add 10 to both sides of the equation, and I'll get that y is equal to 4. All right, so then again, I told you we should write it in XYZ form as an ordered triple. Our x was negative 1. Our y was 4. And our z was 7. Okay, and remember, I suggested very strongly that you choose one of the other 2 original equations. So one of our other 2 original equations here, so either 2 or 3 as a check. Some books suggest you do it in both of them. All right, don't use the first one that I just used here, because again, if you made your mistake, it's going to be okay on the first one. So always choose one of the other 2 originals. So again, I'm going to tell you to check your answer. All right, as I said before, it would make sense if you're going to, on a test, you want all full credit. So it would make sense to me to go ahead and do that. All right, so then I said sometimes you might use substitution instead of elimination when solving systems. So this example, solve this system using the substitution method. So again, just like before, with the first example, we're going to call them 1, 2, and 3. All right, and then here on step 1, this time, I want you to solve let's say, again, if I'm looking at all of them here, all right, if I'm looking at all of them right here, I see that this one is the only one with the coefficient of 1. So I'm going to solve 1 for y. And if I do that, that'll give me y is equal to, again, I'm moving everything over. The 1's already over there. So when I move the 2x over, it's going to become positive. And when I move the 6z over, it's going to become negative. All right. So now you're going to plug into 2 and 3 to get a system of 2 variables. All right, so excuse me there. So if I go with 2 first, all right, I have 3x. Then I have plus 2. Again, my y now is 1 plus 2x minus 6z plus 5z is equal to 16. And I'm going to distribute that 2 through the parentheses. That'll give me 3x plus 2 plus 4x minus 12z plus 5z is equal to 16. Again, I'm going to combine the like terms. So I'll have 7x minus 7z. I'm going to take the 2 and move it over to the other side, and that'll give me 14. Remember on this one here, I suggested that you could factor out a 7. Then I'll have 7x minus z is equal to 14. Now I can divide by that 7, and that will give me x minus z is equal to 2. And remember, I'm going to call that one now equation 4. Now if I take 3 and do the same thing, so on 3 I'll have 7x plus, I'm going to have 3. I'm replacing y now with 1 plus 2x minus 6z minus 4z is equal to 11. Again, I'm going to distribute that 3 through the parentheses. That'll give me 7x plus 3 plus 6x minus 18z minus 4z is equal to 11. Again, I'm going to combine like terms. 13x minus 22z. Moving that 3 over to the other side with the 11 will give me 8. And on that one, again, that'll be equation 5. Okay? So now, remember, I told you that I need to get rid of one of the 2 variables now. This time I'm going to have to multiply either 4 by 13 or by 22 to get rid of the x or the y. So what I chose to do is I'm going to multiply 4 by negative 13. All right. So again, like I just said there, what I'm going to do is I'm going to take negative 13 times 4 plus 5. When I do that, again, I'm looking at this one here. If I multiply it by negative 13, I'll get negative, let me go back to blue. I'll get negative 13x. Negative 13 times a negative z is plus 13z. And then negative 13 times 2, notice I'm multiplying everything. That will give me negative 26. And then the second one, I'm going to have plus, and that one's going to stay the same. I'm going to have 13x minus 22z is equal to 8. So now, again, if we look, those are going to go away, the x's. So I'll get negative 9z is equal to negative 18. And if I divide through by negative 9, that'll give me that z is equal to 2. Again, after that, choose 4 or 5 to solve for x. All right, so I chose 4 because it was the easier of the two. So on that one there, I'll get that x minus, we just said that z was 2, is equal to 2, or we'll get that x is equal to 4. And then finally, step 3, like I said before, use one of the original 3 equations. Well, since we have to solve for y, I'm going to go ahead and use 1 because that already has y as a coefficient of 1. So I'm going to take negative 2 times 4 plus y plus 6 times 2 is equal to 1. So I'll get negative 8 plus y plus 12 is equal to 1. Again, I'll combine like terms. I'll get y plus 4 is equal to 1. To get y by itself, I'm going to subtract 4. 1 minus 4 is negative 3. Again, you're going to put it in x, y, z form. So x was 4, y was negative 3, and z was 2. Again, check. It doesn't hurt you to check, ladies and gentlemen. In fact, it only helps you. All right, so that's kind of where I finished the notes today. But I did tell you I was going to go ahead and finish the whole things for you and put it up for you. So I will go ahead and do that. So when you obtain a false equation, such as 0 is equal to 1, in any of the steps, the system has no solution. So example 2. Now in the first two, I just had example because I wanted to do one with substitution and I wanted to do one with elimination. So remember, on this one here, the example 2 would follow the one in the textbook for you. So again, I'm going to still do the same thing as I've done with the other two problems. I'm going to call them 1, 2, and 3. All right. And now on this one here, we got to get rid of something. Okay. So I'm going to look at this one here, and I'm going to notice that I have a 6x here, and I have a 12x here. All right. So if I multiply the top one, number 2, by negative 2, that would give me a negative 12x. And then I could add them, and that would make the x's go away. So what I just said I'm going to take negative 2 times 2, and then I'm going to add it to 3. All right? So if I take negative 2 and multiply it all the way through number 2, negative 2 times 6x is negative 12x. Negative 2 times 9y is negative 18y. And negative 2 times negative 12z, negative times a negative is a positive, so that'll give me 24z. And again, I still have to multiply everything. I said everything, so negative 2 times 14 is negative 28. Okay, now the second one, 3 was just 12x plus 18y minus 24z is equal to negative 11. All right, so now notice what happens here. On the left-hand side, 12x, negative 12x plus 12x, well, that goes away. Negative 18 plus 18, that goes away. And 24 minus 24 makes that go away. So on the left-hand side, I have 0. Again, I'm adding this, ladies and gentlemen. So on the other side, I have negative 28 plus a negative 11, and that will give us negative 39. All right, but, and let me go up here, we know that 0 does not equal negative 39, so you're going to have no solution. All right, so the no solution ones are kind of simple. All right, and now here's the ones that kind of is not hard, it's just involved. So when you do not obtain a false equation, but obtain an identity such as 0 equals 0, 5 equals 5, something equals something, the right things match, then you're going to have infinitely many solutions. But we're not just going to write infinitely many solutions. We still have to write it as an ordered triple. On some of the questions on the worksheet I'll probably give you, it won't say that, but again, follow this and you will not be steered wrong. Okay, so again, I'm still going to do the same thing I always do. So I'm going to do 1, 2, and 3. All right, and it looks like here I can take, again, I'm going to look at it. I have minus 2y here. I have minus 2y here, but I have a plus 2y here. All right, so I'm going to take 1 plus 3, and it looks like I'm going to take 2 plus 3. All right, so to do that, I'm going to have 2x minus 2y plus 2z is equal to 12. And then I'll have 2x plus 2y plus 2z is equal to 12. Again, this case, it's not always going to be the y's. Just on my examples, for some reason, it did become the y's. So if I add those again together, I'll get 4x plus 4z is equal to 24. Now remember, I can factor out a 4. And that's not always going to happen. It just happened again on these ones that were chosen. And now I can divide by 4. So our fourth equation becomes x plus z All right, so that's our equation 4. I'm going to do the same thing now. I'm going to take my 2 and 3. So I'm going to go 2 plus 3 and then see what happens. So when I do 2 plus 3, I'm going to have 10x minus 2y plus 10z is equal to 60. I'll have 2x plus 2y plus 2z is equal to 12. Again, minus 2y plus 2y goes away. So I'll have 12x plus 12z is equal to 72. I'll tell you on this one, same thing. The 12 I can factor out, so I'll have x plus z is equal to 72. And when I divide through by 12, equation 5 now becomes x plus z is equal to 6. So on step 2, now look, I have x plus z is equal to 6. I have x plus z is equal to 6. So I could either multiply one of them by a -1, or you can realize that the same thing you're going to do is you're just going to take 4 and subtract 5. So if I take 4 and I subtract 5, I'll have x plus z is equal to 6. And then again, I'm saying I'm going to subtract the whole thing. So I'll have x plus z is equal to 6. Okay. X minus x is at 0. Z minus z is 0. So on this side I have 0. And then here, 6 minus 6 is equal to 0. So again, just like on the previous one, we had 0 is equal to 39, and that one was false. So we can't have a solution. On this one here, we have 0 equals 0, all right? Which means that's a true statement, and there are infinitely many solutions. Okay, now I have to describe it as an ordered triple. So when I see that, ladies and gentlemen, all right, you're going to choose, again, look at these two here. We're going to look at 4 or 5, all right? So you're going to choose which variable to solve for. So choose from 4 or 5. Which variable to choose from. Excuse me, which variable to solve for. All right, and again, it doesn't matter, ladies and gentlemen. I'm just going to tell you, for some reason, I chose Z. All right, so on that, remember, we're going to have X, we're going to have Y, and we're going to have Z. All right, so now I want you to think about this. if we solve, here, let me go back to blue. I'm going to solve for x. If I do that, then I'll get that x is equal to, again, look at that one there, x is equal to 6 minus z. All right? So now, what I want you to see here is your ordered triple here. Again, I told you that I just chose z. All right? So when I say I chose z, that means I'm going to have z here. When I solved for x, that is what's going there. So I'm going to have 6 minus z here. And then finally, you're going to solve. Again, choose one of the three original equations. So I said solve for y, because that's the only one that's left. Remember, here's your x, here's your y, here's your z. We have to figure out what y is. So I said solve for y, and in this case, I chose 1. So n1, I guess I should write it right. Okay. So again, I'm looking at the first one there. I have 2, right? And then my x now is 6 minus z. I don't know what my y is yet. And then I have plus 2z. And that's going to equal 12. So I'll have 12 minus 2z minus 2y plus 2z is equal to 12. Notice I have a minus 2z here and a plus 2z here. They're going to go away. So now I have negative 2y. If I take that 12 over and move it to the other side, 12 minus 12 is going to equal 0. So in this case, and it's not always going to be a 0, ladies and gentlemen. It just worked out this way here. We're going to have y is equal to 0. Again, we're going to put that one right there. So our ordered triple is 6 minus z, 0, and a z. All right. So one of the problems I give you tomorrow will have one like this. Again, it's just going to depend on which one you solve for. I'll kind of see, I'll give you a hint which way they probably will want you to go. That'll probably help you a little bit. But again, it doesn't matter. Just look at 4 or 5. In this case, I had x and z. So I had to choose for x or z. I could have easily chosen for x too. Okay? And then finally, our last one's a word problem, because we're trying to give you more word problems, ladies and gentlemen, because word problems are more what real life is. So Colin has $1.27 in quarters, nickels, and pennies. He has twice as many quarters as pennies. He has 11 coins total. How many of each coin does he have? So we're going to define the variables. Again, I let x equal pennies, y equal nickels, and z equal quarters. All right, and then we need to write a system of equations. So again, we have 3 equations. We should have 3 unknowns. So on our first one here, you know that you have 11 coins total. So we know that we're going to say x plus y plus z is equal to 11. All right. For the second one, we know we have twice as many quarters as pennies. So if we have twice as many quarters as pennies, we're going to be able to say that Z is equal to 2 times X. All right. Now, on the last one, it's the total money counted equals $1.27. So again, I'm going to say a penny is worth 1/100th. So we're going to say 0.01x plus 0.05y, there's a nickel, and then plus 0.25z is equal to $1.27. All right. Now, I would say if you don't like decimals, get rid of them, because on this one here, again, this would be our equation 3. So let me put that in front. So if we multiply 3 by 100, okay, it's going to move it 2 decimal places. All right, so if we do that, then that will lead us to x, again, because it's moving it 2 decimal places, it's moving it 2 decimal places, it's moving it 2 decimal places. So I'll get x plus 5y plus 25z is equal to 127. All right, so on this one here, it's kind of easy because we already have one solved for one of the equations. All right, we have this one solved for z. So we're going to substitute 2. So we're going to substitute 2 into 1 and 3. All right. So on the first one, we're going to substitute in 2x for z. So we'll have on that one, we'll have x plus y plus 2x is equal to 11. Again, if we simplify that, we'll get 3x plus y is equal to 11. And that will be our equation 4. In the other one, we're going to get x plus 5y plus 25. I'm replacing z with 2x is equal to 127. Again, 25 times 2, that's 50, plus 1, that'll give us 51. X plus 5y is equal to 127, and that will be our equation 5. Again, I'm looking at this. Which one do I want to get rid of? Well, I see a y here, and I see a 5y here. So I think if I take 4 and I multiply it by -5 and then add it to 5, it'll go away, all right? So the y will go away. So I'm going to take, like I said, I'm going to take -5 times 4, and I'm going to add it to 5. Okay. So on that one there, I'm going to have, again, -5. So let me go ahead and I'll work it out for you this time. So I'm going to take -5, and I just tried to change that to blue. Let's do it right this time. So I'm going to take -5, and I'm going to multiply it to 3x plus y equals 11. So again, distributing it out all the way through, ladies and gentlemen, that'll give me -15x minus 5y is equal to -55. And I'm going to take equation 5, and that one was 51x plus 5y is equal to 127. All right, -15x plus 51x will be 36x. Again, the y's are going away, and I'll have 36x -55 plus 127 is equal to 72. Divide both sides by 36. I'll get that x is equal to 2. All right, so now it's easy to look at the second one. So I'm gonna plug in x is equal to 2 for the second one. So I'll get z is equal to 2 times 2, which is equal to 4. And then step 3, use 1, 2, or 3. I think 1 is still the easiest one. So I'm going to take and get 2, which was my x, plus y, plus my z, which is 4, is equal to 11. Combine like terms, y plus 6 is equal to 11. And then y is equal to 5. Again, I'm going to put my solution in XYZ form. So I'll get x is 2, y is 5, and z is 4. And I'm all done. All right, so the notes are a little long, but again, I tried to put them in order for you here. Again, watch this if you need help. All right, I will do the second part for you again tomorrow in class, but I will put everything on there right now. So thank you, people, and good luck.